Alright, so if I rewrite this as 2x plus 3, and the exponent will be what?
1/2.
Raise it to the 1/2. That's not a y, that's a 1/2.
Would it be negative since you moved it to the top? Be negative 1/2.
Exactly, because we moved it to the top, so it's negative. And any square root is the 1/2 power.
You're recording this. You put this on YouTube?
Yes. I put the other review on YouTube, so I'll put this one on there too. So I have both of them. Then it's a chain rule. The outside would be 2 negative 1/2. The inside would be 2x plus 3. So then the derivative of the outside would be 2 times negative 1/2. And within negative 1/2 minus 1 times 2, because the derivative of the inside would be 2. So then this part, the 2 times the negative 1/2 is going to give me negative 1 times this 2 out here is going to give me negative 2. Then I leave the inside in there. Right, it's 2x plus 3. Then negative 1/2 minus 1 is negative 3/2. And then I already got rid of that 2. The only other thing we could do is what? Move it to the bottom. So it would be 2x plus 3.
I thought the 2 times negative 1/2 would be negative.
When I move this to the bottom, it shouldn't be negative. I don't know why I still put a negative. When I move the exponent to the bottom, it's positive, so this was my derivative. And really, I guess this was y equals, so we should say y prime is equal to, is equal to y prime. There we go. You got it.
Yep.
Alright, so this one, we've got a function times a function, so we could say, let this one be f and this one be g. So if we use product rule, it's f times g prime plus f prime times g. So f is just x to the third.
Where's the 4? What's the 4?
I need to record this. So f is x cubed, and then g prime, I just want to look inside the green box. I want to take the derivative of what's in the green box.
So really, we could, like...
I need an out.
So prime just means you're taking the derivative, right?
You're
Right.
still going to do the out and the in, yeah. You're just going to do it on the other part. You don't include x.
The derivative is going to be 4 times undo 5x minus 1 to the third times 5. So it would be 20 5x minus 1 to the third. So that's what's going to go in place over here. 20 times 5x minus 1 to the third. Plus, we're done. I'm just making sure y'all got called up. F prime, so I need to take the derivative of f.
3x2.
Yeah, 3x2 times just whatever g is, which is 5x minus 1 to the fourth. Then I can combine like terms if I can, which I don't really have any. So I can just rewrite it as 20x to the third, 5x minus 1 to the third, plus 3x squared to the 5x minus 1 to the fourth. And I would just write it like this. Start over.
Okay, I got this one.
Alright. We're in the middle of the quotient rule. So low times the derivative of the high minus high times the derivative of the low over low, which is just the bottom term squared. So then we need to see if we can simplify something. I can distribute the 6x out. That would give me 6x squared plus 18x minus 3x squared, because it's times 1, over x plus 3 squared. Sometimes the top will factor out to where we can get an x plus 3 and cancel one of them out or something. So we can combine the 6x squared and the negative 3x squared and get 3x squared plus 18x over x plus 3 squared.
One go.
Do what? Which one? This one?
Yeah.
Alright. 1 times 3x squared is just 3x squared.
Is this going to be harder than the last?
I would. So on the top we can pull out an x and a 3. So it would give me 3. It would give me 3x. If I pull a 3x out of this term, it gives me just x left. Pull a 3x out of that one, it gives me plus 6 over x plus 3 squared. So what happens sometimes when we do the chain rule is, like, when I factor that out, this would say x plus 3, and then I could cancel this out and one of these out, so it would be 3x over x plus 3. It's like sometimes that's why you need to do it to see what will cancel out. So if I would have made this to where when I pulled to where this equaled 6x squared or something, so when I pulled a 6 out, it would give me x plus 3. Then I could have canceled one of those out. Does that make sense? To this problem, this is my answer. That circle right there, that box, that I boxed in is my answer.
So basically,
How do you know when you're
It depends on what the multiple choice test is. I would think on this on this answer, this one would be the answer. That's what I would think. On a multiple choice test, they would probably say that's the answer. But you should be able to see it. They're not going to have both of these answers up there. They're going to have one or the other. If one of those answers is there, then pick it. If neither of those answers is there, see if it. They're not going to have this one because you can combine like terms there.
If you were to pull out the bottom,
The way you'd set up the last one, you talking about this big cube root?
That's exactly how much this one was.
I don't know if we went over this or not, but change it to a power. You can change the cube root. What would the exponent be? 1/3, because it's cube root. Like square roots are 1/2, so cube roots are 1/3. So then it would just be a chain rule.
Yeah.
Then it'd be a chain rule where the outside would be to the 1/3, and the inside would be 3x cubed minus 4x plus 2. Then you could do derivative of the outside, which I would bring the 1/3 out. Minus 1/3 be negative 2/3 of 3x cubed minus 4x plus 2 times the derivative of the outside, which would be 9x squared minus 4. Then, since I've got this fraction here and I've got a negative exponent, I'm going to have a fraction answer. So I'm going to take everything, see what goes on the top. This 9x squared minus 4 would be on top. This 3 would be on the bottom. And this whole thing here would be on the bottom.
How are you going to do the cube root thing?
Or if we don't, we could also see the answer with the radical.
I can't listen to it anymore.
So it would still have the 3 out front. The radical, whatever's on the bottom of the fraction, which is 3, that's what the radical, that goes with the radical. So it's cube root. And then what's on the inside would be squared, because the 2's on top.
so if you ever have anything except an x or just a number,